Hello and very welcome to a snowy day. It's been snowing for 2 days here in Gotland, which is excellent for the recharge of the groundwater aquifers, which we really welcome. However, I also would like to take this opportunity to take a pristine sample of fallen snow to check the conductivity and pH of the snow. So let's go out and take the sample. I have made a special sampling. I've shoveled away to make a sampling road. So let's take a walk out and take a sample. So now we have the sample of pristine snow from Gotland, and we're gonna let it melt, and then we go over to the waterworks and measure the conductivity and pH of this snow that we now picked up. Before we start the measurement of the melted snow, we have calibrated the pH and conductivity meter, which is of hack type. And also I'm going to check the turbidity in the molten snow. And of course the values, pH, conductivity. pH, we'll see what it is, that will be quite exciting, but the conductivity and turbidity will of course be low, given that it's basically condensated water in the form of snow that we now are going to look at. And just a note, you see the notepad here, I'm old-fashioned, so even if the instruments are storing the calibration points, for instance the pH, the millivolts, I always make a hand note. But again, the calibration values you can find in the instrument to follow up on the analysis you've made, of course. Now we are ready for the measurement of pH and conductivity. And on the left hand side you see the jar, which we now have the molten snow. And here I will zoom in. Here you see the pH and conductivity meters, and here you can see the instrument we are going to use, and I'm just going to zoom in. And since we are in Sweden, it will be Swedish text, of course, but here you see the micro Siemens per centimeter for the conductivity measurement, and below that you see the pH. So let's see what the very intriguing answer will be when we check the jar with the molten Gotland snow. Now we made a measurement, and to be very clear, before we put the probes in the jar with the molten snow, we clean them with deionized water to have them completely clean, so to speak. You didn't see that because I would like to make the film also, and it was a little bit messy if I'm gonna try to film at the same time. But let's see the results. Now we're going down, we're coming close, and here the snow in Gotland that we picked up in the jar, the sample is 6.23 microsiemens per centimeter, and you can see the pH is 6.28, and the pH I would expect that, and it's important to know now when we talk about this that it's a very soft water. There are very few minerals in the molten snow, of course, because it's condensated water. And that pH could be or can be expected. But you can comment in the comment field about conductivity and pH, but here you have the results for the snow. Now we're going to look at the turbidity also of the same sample. And I took a sample before I put the probes in the jar. I took out the sample and for the turbidity. So let's have a look at the turbidity. Now we also have the answer for the turbidity, or measured turbidity by the hack instrument. And let's have a look at the display. And it says 0.91 NTU. Now, for you who are familiar with the measurements, you probably have some thoughts about this. And as a note, this turbidity meter can measure from, well, 0.1 up to 1000 NTU, so you have a very wide span. But before we did the measurement, I of course took the calibration using the 10 NTU calibration solution. But this is just one example of how turbidity in snow can be. So with that, we go over to the closing remarks for this video. To summarize, most important in this exercise, so to speak, is how you collect the sample. And in our case, we made sure that we took the snow sample where we definitely knew there was nothing to contaminate it. For instance, if you would take a snow sample from the roadside, it would definitely be contaminated if you were looking at, how should I say, pristine snow. Also, it's very important to calibrate the equipment you're using. This, of course, it's a no-brainer, but it's always important to do a proper calibration, to write down the calibration values, and also, for one example, the pH meter, which is a crucial measurement when you're looking at water production or water treatment, of course. So calibration is always very, very important, which I've showed you a little bit of here. Turbidity, the calibration of 10 NTU, and of course the standard calibrations 4, 7 and 10 for the pH meter. With that, as I said, we're standing in the waterworks here, now in the Maldes Water Centrum. And in a few days we'll start up the PLC here in the waterworks, and probably in May we'll have a course, and the people coming to this course will of course do a lot of measurements, process operation, and looking at the PLC control, so forth and so on. But for now, this was just, how should I say, a snowy example of how to make some measurement. With that, I wish you a very good 2026, which has just started. And hopefully you can see some videos, maybe at YouTube, that I make, or maybe we can meet here on a course of some sort. But take good care, have a good 2026. Bye bye.